Good day, everyone. Welcome to another day of fun and learning. It's me, Teacher Jen. I am so excited to share awesome math concept with you. Before we start, let us be reminded by the following rules. First, stay alert and focus to the video lesson. Second, prepare your pens, papers, and activity sheets. Third, sit back, enjoy, and relax. Let us start our discussion with this situation. Given this picture is 2 kilograms of rice and its cost, if the number of kilos of rice increases, what will happen to its cost? Very good. It will also increase. How about if the number of kilos of rice decreases, what will happen to its cost? Yes, it will also decrease. Let's have another picture. If we have here the speed and the distance, for example, if you travel using the speed of 6.5 km for 3 hours, the distance covered will be 19.5 kilometers. Let us compare if you use lesser speed for 3 hours. What will happen to the distance you travel? Correct. The distance covered will also be lesser. These situations are the examples of direct variation. Our objectives for this day are: first, illustrate situations that involve direct variation. Second, translate into variation statement a relationship involving direct variation between two quantities given by a table of values, a mathematical equation, a graph, and vice versa. What is direct variation? A direct variation shows relationship between two variables, example x and y, that can be written as y is equals to kx, where k must not equal to 0. As mentioned earlier, the direct variation is represented by this equation y is equals to kx. This equation can also be read as y varies directly as x, y is directly proportional to x, and y is proportional to x. The k in the equation is the constant of variation that relates the two variables. Example, the constant is 2. Given this table of values, the x and y, and the x are 1, 2, and 3, what do you think will be the values of y? Correct. We have 2, 4, and 6. Using the equation y is equals to kx, substitute the value of k, which is 2, and the values of x. In other side, what will happen if we divided the values of y to the values of x? Yes, as we can observe, they have the same quotient, which is 2, which is the constant of variation. Therefore, to get the constant of variation, we have this equation: k is equals to y over x. In direct variation, it is important to familiarize these two equations. As we can observe in the table, if x increases, the values of y also increases. As x decreases, the y also decreases. Let's have more examples of direct variation in real life. You identify if it is direct variation or not direct variation. Do a thumbs up if it is direct variation, and thumbs down if it is not. Tickets sold and profit of a concert. Very good. This situation shows direct variation. Because more tickets sold, more money will be raised in a concert, or less tickets sold, less money will be raised in a concert. How about this one? The number of persons sharing a pie to the size of the slices of the pie. Correct. This is not direct variation. Because the more person will be sharing the pie, the sizes of the slices of the pie will be lesser. In short, more person, less pie, or less person, more pie. So this is not direct variation. Now, let us learn how to translate each statement into an equation that shows direct variation. Let us use K for the constant of variation. Write your answers in your notebook. Number 1. C varies directly as B. Can be translated to? Correct. The equation is C is equals to KB. The variable that be isolated is the one we'll read first. Number 2. M is directly proportional to N. Can be translated to? Correct. We have M is equals to Kn. And number 3. A is directly proportional to the square of S. Can be translated to? Correct. The equation is A is equals to Ks squared. And that's how to translate variation statement into an equation. How to determine if the table of values expresses a direct variation or not? In order to say that the table of values expresses a direct variation, we must check first the relationship of two variables. If x increases, y must also increase. If x decreases, y must also decrease. And the constant of variation must be the same. Let's have this table. Will the value of x increase as the value of y increases? Check. How about constant of variation of the given values? Are they the same? Check. Therefore, this table of values is a direct variation. Let's have this another table. Is it direct variation or not? Yes, it is direct variation. As 10 divided by 30, 5 divided by 15, 3 divided by 19, the K is 1 over 3. And to determine the equation of variation, all we have to do is substitute the values of K in the equation y is equals to Kx. So we have y is equals to 2x. Now, the equation of variation is equal to y is equals to 2x. For us to determine if the graph shows direct variation, first, check if the graph is a straight line. Second, it must pass to its origin. This is an example of the graph showing direct variation. So, we already know the concept of direct variation. Now, it's your turn. Determine whether the given statement is true or false. Write your answer on your paper. I will give you 10 seconds to do that. Very good, students. Thank you for your active participation. See you again in our next lesson.